Hello and welcome to another GCSE revision video, and in this video we're going to be looking at the rectangle. If all four angles of a parallelogram are 90 degrees, then we have a rectangle. A rectangle is a special case of a parallelogram. If the width and length are different, then the rectangle can also be called an oblong. If the width and length are the same, then the rectangle is also called a square. An oblong cannot be a square, and a square cannot be an oblong, but both squares and oblongs are rectangles. A rectangle has at least two lines of symmetry, and a rectangle has at least two orders of rotational symmetry. Opposite lengths are the same, and all four angles are 90 degrees. The diagonals are equal in length and do bisect each other, but not necessarily at 90 degrees. Opposite sides are parallel and adjacent sides are perpendicular. The perimeter of a rectangle is 2 times the length plus 2 times the width, or 2 times the sum of the length and width, although you can just go round the outside adding up the various measurements. And the area is the length times the width. It probably shouldn't be your highest priority for your revision, but if you do insist on knowing how to calculate the area of a rectangle using just the diagonals, and there is a slim chance it might show up, then it's just a half times diagonal 1 times diagonal 2 times the sine of the angle between the diagonals. Okay, let's just derive that point so that we can be sure of what we're talking about. So here's a rectangle, and let's just draw in the diagonals. If I can try and draw them nicely. So I'm going to call that diagonal 1, and I'm going to call this diagonal 2. I'm going to call that diagonal 2. Now, one of the properties of a rectangle, well, of any parallelogram, is that diagonals do bisect each other. So this length is equal to this length, and this length is equal to this length. Although if it's a rectangle, then this length is equal to this length as well. So both diagonals are actually equal to each other and they do bisect each other, but not necessarily at 90 degrees. Now, the properties of straight lines tells us that if this angle is x, then the opposite angles are the same, so this angle must also be x. And adjacent angles are supplementary, so this angle must be 180 degrees minus x. And opposite angles are the same, so this is also 180 degrees minus x. Okay, so let's pick a triangle. I'm going to pick this one, and we're going to try and find the area of this triangle. Well, we know that this length here is a half of D1, so I'm going to call this length A, and I'm going to call this length B, if I can get a colour that can be seen. Let's say this is A and this is B, and I'm defining A is equal to D1 over 2, it's half the diagonal, and b is equal to d2 over 2. Okay, now the area of a triangle, we know from our trigonometry, is a half a b sine x. So it's a half of length 1 times length 2 times the angle between them. And this is an important trigonometric formula to remember for the area of a triangle. It's as important as a half base times height, to be honest. Alright, so what else can we know? Well, we can know that there's another triangle that's going to be congruent, and that's this triangle, because this length is the same as this length, and this length, well, actually this length is the same as this length, and this length is the same as this length. So we can say that this is also length A, and this is also length B, because they both form the half of the diagonal. And this angle is the same, and these two lengths are the same here. So we've got two congruent triangles. Now what about the other two triangles? They're clearly not congruent because the angle's different and the lengths are different. But they do have the same area, because the area of, let's choose this reddish colour, the area of this red triangle is a half of A times B times the sine of 180 degrees minus x. And I've said it loads of times as if it's a matter of fact, but I might actually consider making a YouTube video to prove that the sine of 180 degrees minus x is equal to the sine of x, that it's a well-known trigonometric identity. So this area is the same. So if I just pick another colour, so the opposite triangles are congruent, and therefore all four triangles have the same area. So if we say that the area of one of the triangles is a half of A, which is d1 over 2, times B, which is d2 over 2, times sine of x, and if we want the whole of the rectangle, or even the whole of a parallelogram, because this argument applies to a parallelogram as well, then we have to multiply all of this by 4. Well, if we're multiplying by 4 and dividing by 2 3 times over, then this is basically, that 4 can cancel with the over 2 on the d1, and that would leave a 2, and then that 2 will cancel with the over 2 on the d2, leaving us with just a half of d1 d2 sine x. Now it really isn't important for you to memorize this formula, because as you saw, it's fairly easily derived from the very important trigonometric formula, a half a b sine c, for any triangle. Now this is for a triangle where you're given two lengths. So that's length A and that's length B. And C is the angle between the two lengths. And given those conditions, a half AB sine C will give you the area of the triangle. And that is the one you definitely need to remember for your exam. This one, it's optional if you want to remember it or not, but you can very quickly derive this one from this one. Okay, I hope this video was helpful. If it was, don't forget to like, comment and subscribe. If you are taking your GCSEs this year, I'd like to wish you all the best with your revision and all the best with your exams. And I look forward to seeing you in another video.